Hello everyone, welcome to my data science final project presentation. My presentation topic is propensity to buy model for Jekyll to Excel. Before I tell you what I mean by propensity to buy, let me give you a quick background of Jekyll to Excel. So jekyll2excel.com is actually a website that I built. It's a SaaS web app. It allows people to download Google Calendars as Excel file and do some reporting on top of it. It has 2 paid plans and 1 free plan, and people can also use it for free for a limited trial period. The reason for doing this is that I want to increase jekyll2excel.com's revenue by targeting users who are more likely to buy. So the goal is to find potential paid users or users who are likely to pay. So to do this, I figured I will actually have to find users who are similar to our current paid user base. So if we can find people who has similar behavior as our current paid users, we can actually identify them and then target those users. I also want to know what feature actually matters for unpaid to paid conversion. This would allow me to focus more on those features as they are likely most useful to our users. So I had actually 2 strategies to find similar to paid users. One plan is to create a model that can actually classify paid versus unpaid users. And the goal here is not to have a very accurate and precise model. Instead, my goal is to increase recall so that I can actually identify most of my paid users, and I can still have false negatives. So those users who are wrongly identified as paid users, in this case, would be my target user. Basically, they are the ones who are more likely to buy. I will also use random forest, as random forest actually gives me feature importances out of the box. I can use it later on to develop my product. The next strategy I had was clustering strategy. So I was thinking of using k-means and create 2 clusters. Because I have a very unbalanced data set, because most of the users are unpaid now. So we have very low amount of paid users than free users. So most likely the k-means will identify one small cluster, and most likely that small cluster will contain most of my paid users, and other users in that same cluster can also be considered as likely to buy users. So now that I have 2 strategies in place, let's look at the data source. So I have 3 different data sources. One is users account data, the other one is template logs and export logs. So all 3 of these data sources are in a MySQL database. I actually picked last 90 days data from 3 of these tables. Basically what I did is picked users who were active in last 90 days and then picked their activities from template and export tables. Good thing is template and export, both tables contain user ID, so I can actually join them with my user data in Python itself, even though I have 3 different files. Let's look at the data files. The first one is user data file. It's called users 90 days CSV. It contains all user information like user ID, name, when that user was created, if that user used recurrent export feature or not, and their customer ID and plan. So on the right hand side you can see plan distribution. Basically you see a lot of basic users, and then I think 1/4 of them are professional and personal users. And one interesting note here is that some of those professional users might not be paid users though, because they might be trialing. So how do I know who is paid or not? Basically, if customer ID contains some value, it means that the user is a paid customer. If it doesn't contain any value, it means the user is not a paid customer. So the plan information is actually doesn't matter really. Then let's look at the template data file. Every time a user creates a template in the website, it creates a record there. Again, it contains user ID, name, a JSON data dump, created at and deleted at timestamps. So on the right hand side, that pie chart shows like, okay, how many of our users, like from total user base, actually has templates and how many of them don't use template at all. On the bar chart, we can see that number of templates versus number of users. So most of the users who has templates, they have like only one template. Okay, so let's look at our last file. It's called export data. It's the file name is exports 90 days CSV. It contains all export events. So every time someone exports in our website, it actually creates an event there. This CSV file contains user ID, file name, created, and data. So data is basically a JSON blob. It contains more information about the event itself. I actually extracted a lot of information out of this data field. As an example, here I can see like controller equals to export, which actually denotes that this export was a manual export, not a recurring automatic export. So we can actually get a lot of interesting information from this data field. Also, I have this bar chart that shows like number of exports versus number of users. So as I can see, like most of the users only exported once. But again, we have a very long tail, like some of the users even did it for 611 times. So here's the final feature set that I extracted from user data, template data, and export data. From user data, I figured paid versus unpaid from customer ID field. I also figured days since from the created at field. Days since is basically days since registration. From template data, I actually figured number of templates a user created. And from export data, like from the JSON blob, I figured out how many recurrent exports that user did, how many regular export, manual export that user did, and number of calendars per export. So I actually created a list with number of calendars per export and then got the 90th percentile of it. Also, one interesting thing is like some of the export record doesn't contain data. So basically the JSON blob is not there. So what I did is that for that I actually figured out the regular versus recurrent export ratio from known data. And then for those unknown exports, I guessed recurrent or regular export. So basically I splitted unknown exports into recurrent and regular based on known information. So now that we have looked at the data, let's see how I build the classification model. So I used random forest classifier to build a supervised model to identify paid versus unpaid users. One interesting thing, as I was mentioning before, that our data set is pretty unbalanced. We have more than 7,000 free users, and we have around 461 paid users. So for our model to work well, we need 50-50 data split between paid versus unpaid. So I cannot increase number of paid users. So what I did is undersampled free users. Basically, I took random 461 free users from that big pool. So for tuning, I use grid search CP to actually find the most optimal model configuration for best recall. So here is the classification performance. Accuracy was 0.85, which is not too bad, although we did not really optimize for accuracy. The 5-fold CV score was pretty close to accuracy, which was 0.84. And AOC score is 0.93, so pretty good coverage there. Classification performance. So this is actually what we are looking for, recall. We have 0.98% recall. However, the precision is 0.78, but it doesn't really matter because it's fine to have false negatives. So feature importance. So random forest actually gives us like feature importance out of the box. And one interesting thing we found here is that recurrent export actually doesn't really matter much. Also like number of calendars, not too much. However, template is much more important, which I didn't really realize before it. Once the classification was done, I did some clustering using K-means. I created 2 clusters from the data. As expected, one cluster was pretty small than other. And then what I did, I actually found the intersection of paid users for both cluster 1 and cluster 2 and found that most of the paid users fall into cluster 1. So cluster 1 is probably the one that contains users who are like our paid users. So now that we have our clusters and models ready, let's dig into the data and see like what we discovered. So again, like the goal is to find those false negatives, basically unpaid users who are predicted as paid users with high probability. We can actually select them for targeting. The random forest actually returned 1900 unpaid users predicted as paid users with 50% probability. However, most of the users are not likely to buy because they were under 10% probability. So we can actually remove them from our campaign with a higher level of certainty. So on the right hand side, we can see the distribution. So this is basically 0.9% probability, like we have a very small number of people there, 0.6 pretty high. But if you see like 0.1 is pretty high too, like it's like 3,500. So these users probably are not too active or they're very recent. So here is another way to dissect the data. Around 25% of unpaid users are likely to buy because they have like greater than 50% probability. If you see the pie chart, like 1/4 of them are green. Basically, they have 50%, higher than 50% probability to convert. Whereas around 20%, those yellow ones are between 20% to 40% probability. So maybe like we need to message them differently when we are marketing to them because they are not as inactive as the rest of 55%, but they are not too active as well. And here is another way I dissected data. Basically, using k-means, I found 1,571 users who are likely to purchase based on their cluster residence. Basically, I figured out how many people are there on cluster 1. So as we can see, this is pretty close to the number we got from random forest. I then actually created an intersection of both of the models predictions. Basically, k-means said 1,571 and random forest said 1,900, and I found 1,263 users are present in both the predictions. So these users probably has got the highest chance to purchase because both models sort of like identified them as similar to our paid users. So here's the final result. We have around 1,200 to 1,900 more users who are likely to buy, which is around 3 to 4x of our current number of paid users, which is 461. However, a majority of our current users have low to very low propensity to buy. Critical features like templates can be promoted more to engage those users. As we know, like data science is more like a journey, so you can keep tuning. So we can actually extract more features like export file type, maximum number of calendars, template uses data, etc. to tune the model. We can also use MLP to increase model's performance. And then we should actually target those users returned by ML models and see how they do in real world. So we can actually do a A/B test to validate which cluster actually is more accurate, and also like what is the lowest probability percentage needed to convert a user. Okay, that's actually all. Thanks everyone. This is actually my last semester. My commencement is this Saturday, so I'm actually flying to Springfield tomorrow. Thanks, Mike. It was really wonderful. I really learned a lot in this course, and good thing is like my job is data related, so I can practically use whatever you taught. Thanks. Bye-bye.